Okay, let's dive into section 3, looking at information management systems and business software specifically. So, um, almost all of the expenditures for most companies, the biggest piece is going to be in their software. When companies talk about gaining productivity in an organization, every organization is looking at doing this through some sort of software or software program. We no longer are throwing a whole bunch of people at a problem. We're throwing technology at a problem. And so, again, this is all going to be driven by the software piece of this. So it all starts with programming languages. Software developers are going to write computer programs. Again, these are going to be a set of keywords or symbols and rules that construct statements. In essence, it allows human language to be understood, or instructions for the computer. Several languages exist out there. Holy cow. Can't even name them all. Java, C++, Ruby on Rails, Visual Basic .NET, Groovy on Grid. I mean, just on, and they continue to be developed. The syntax is an important piece of all of these. It's a set of rules that are going to be associated with each of the programming language. So literally learning Visual Basic, although we'll have some cross understanding with like .NET, they are their own language. It's no different than Spanish and Japanese, right? They're going to have their own syntax and their own languages. Rules associated with each of those. So, but at the heart of it, every programming language must be able to do four things. They need to accept the data in, store the data, manipulate it, and then have some form of output. So it could be a printer, oftentimes this is on your screen, could be a document to be saved, or whatever. But those four things must be included in every single programming language, okay? Some of the more popular programming languages now are going to be visual programming. So this is where we can actually just combine objects and throw them on a screen. A lot of web templates are made this way. A lot of websites are made this way. If you see any of the advertisements for like a Wix or One-to-One or Box, any of that stuff, those are all kind of visual interfaces for building out websites. Object-oriented programming languages, OOPs, we're going to talk a little bit more about those, but it's just a way of structuring the language into objects. And then you have kind of this higher level of kind of fifth generation, which would be machine learning, artificial intelligence languages. The most human-like interaction that we can get with a computer, that's really what artificial intelligence is all about. So by far the most popular currently is the object-oriented programming language. Again, it's kind of juxtaposition with procedural-oriented programming, which procedural-oriented programming focuses on the data and the task required to produce a result. So everything is broken down into a task, and then the subroutines are used to accomplish the task. Contrast is the object-oriented programming language. Properties, basic kind of fundamentals here are properties, and those are the items that describe the object. Methods are the actions that can be performed with an object, and then the events are the things that can happen to an object. Okay, so let's give an example here of a car. We can describe the car with the properties, the make, the model, the price, the color, the type of headlights, type of tires. We can describe all the different properties of a car. The methods, again, are the actions that can be performed with an object. So we can start it, we can drive it, we can park it, we can wreck it. And these are all of the actions that performed with the object. And then the events are going to be the things that can happen to an object. Okay, so some of the events are going to mirror the object's methods. The event is performed on the object and then changes the state of the object and what methods can happen. So, for example, we can't drive a car before we start the car. And so we call the event on start, and now we can perform a new action or a method with the car, like driving the thing. Okay. And so the basic premise of all object-oriented programming is that these objects are created, and then we can reuse the objects as we're performing different modules with them, right? So it's kind of like this modularized thing. So we can take existing objects and combine them with new objects to create completely new programs. It can easily and efficiently develop new new ideas just by using these existing objects that are out there and then performing things on that. So again, it's more of an efficiency understanding, but it is a little bit better than simply breaking things down by task. Okay, whether it is an object-oriented language or a procedural-oriented language really doesn't matter. They're both going to use compilers and interpreters. We want to think about a compiler as I think about it as the spell checker for computer programming. So the compiler is going to be one of those things that it's going to go through the syntax and it's going to look for errors, and it will not run the program if there's any errors produced, right? The smallest syntax error will cause the program to error out. So if you're missing a semicolon or a comma or words are not put in the right, order, boom, the thing's going to error out. And the pilot's going to say, hey, I don't understand what you're saying. This doesn't make any sense. Cannot compile, cannot put all this together. Once all those errors are cleaned up, then we have the interpreter that in essence says, okay, now I'm going to go ahead line by line and execute your code, but now I'm looking for kind of the logical commands. And so does it make logical sense? So the compiler is looking at, is it following all the rules of the programs? And the interpreter is going to say, does it actually make logical sense? Can I actually perform the task that'll be done? Okay, so there's kind of two catches there that are going on. And again, this is going to happen with just about every program, whether it's a system program or an application program. So let's talk about kind of the differences there. We have software that is in essence, a sequence of events and instructions, right? And we've got documentation for all of these things, but the two basic subsets are going to be system software that enables an application to run on a computer. It's going to control the hardware, the CPU, all of that information. And then the application software is going to help you actually perform a task. So system software is going to be like an operating system. Hey, I'm running Windows 10 right now, and that is my system software. The application that I'm using for this is my PowerPoint, right? It's an application that helps me present and convey information to others. Okay, so those are the kind of basic understandings of the two different types of software. Again, system software, it's going to have a couple different types. Operating system we just talked about. Some other common operating systems are going to be, Mac, the OS. They've got different versions, Lion and Snow Cone and all these crazy names for their operating systems. We have utility programs that help keep the thing running, right? All of these systems running. This is going to be like your antivirus, kind of making sure that the disk cleanup space on Windows. Apple does not have as many of those things. And then the middleware is going to help everything kind of communicate with each other. So middleware is going to be software that allows different systems to communicate and exchange data. Again, just helps interface and bring like the internet and your back office system at your office, kind of working those things together. Okay. Let's see what else here. Here are some of the activities of the operating system: managing files, managing procedures and tasks, controlling the memory, storing all the things that your system needs to run. Okay. And then we have some common terms I definitely want to make sure that you guys understand is the application program interface, an API. This is a pretty common term that gets thrown around a lot within IT, is how do we actually access one program to be able to actually use the services and data from another program, and that's through an API. We're matching fields up, we're making sure that the instructions are going back and forth, and that all happens through API calls and interfaces through an API. Let's see here. Some classified operating systems. Again, we talked a little bit about this, but Microsoft Windows is a big one for business. Mac is making a huge push. Google, we use a lot of the Google applications at Anderson. Looking at their suite of products from Google Documents to Google Sheets and all those different things. So there is different, Microsoft makes a big push for the enterprise, and they're kind of shifting their focus there versus kind of the end user. But there's a lot of different operating systems based upon the needs of the organization, okay, and the need of the user, if you will. All right. And then, of course, we got mobile things. I've only had an iPhone, and so I'm only familiar with the Apple operating system for the iPhone. But obviously, Microsoft has their own Windows-based phone. Google, Android, right? Those are all the operating system for Google, and I think they power a bunch of different manufacturers use the Android system there. So um, again, the application side of it, so that's the system that's going to be running the phone, it's going to be running the computer. On the application side of things, these are going to help us to accomplish a specific task. Okay, and there's tons of different operations for this. Peregrine goes into some of the different applications, some of the popular ones that focus. A business that I own and run, we developed an application for small home-based businesses, and so again, specifically, it's an application to help people communicate and provide training to other individuals, and so again, there's applications literally for just about every need in business. And most of these applications are going to be provided as software as a service. And so you're not buying the software. You typically use it in a cloud setting, right, where you're accessing it via the internet, which works great as long as you have access to the internet. That's always the fundamental linchpin there. And so, but cloud is by far the easiest way to get people their applications quickly and easily. Think about your phone as well. If you have any apps on your phone, your mobile devices, this exact same process where they can push out updates to your phone automatically. If you use any kind of, I'm thinking about the Amazon Prime, the Amazon app that I have on my phone, it'll automatically update at night and let me know of any new versions that are out there. It'll just happen. I don't need to worry about it. So the old days, you had to buy a disc, you had to go to a website. Now all those things just happen. I call it automagically. So but again, some of the more used applications, even in this class, right? You're going to probably use some Excel. You're probably going to use a Word application. I'm going to ask you to use Canvas, which is a software as a service. There's nothing downloaded there. It's all based upon the internet, and it's a specific application that we use in higher education for learning environments. Okay, but there's just these go on and on and on. As the needs change for people, we find more and more of these applications coming around. And then obviously, software can be bundled into suites. And so again, very common would be the Google suite of products, would be the Apple and also Microsoft. There's some other ones in here for sure, Linux and you know some of the free ones that are out there for sure, which work really well. It's just a matter of if no one else has those things, it's really hard to kind of communicate back and forth. So, but as previously mentioned, most of these are going to be web-based productivity tools. Microsoft 365 has really changed, right? We can pay just a monthly subscription and get the applications that we need, and so that's a nice feature. We talked about the mobile applications already, but my brother-in-law, he actually develops mobile apps for phone, and so again, these just constantly changing and morphing into meet the needs of consumers. Business environment, you'll see a lot of like expense. I know there's one here in Indianapolis, Concur, that does a whole lot of expense reporting. You can do all of that from your phone via their mobile application. And so just as many as there are applications for fun and games and all that stuff, the business recognizes that almost a lot of their transactions can be accomplished via a mobile device. And so they are now making sure that they have apps on mobile phones being accessed wherever people are. Enterprise application software is really a focus of the entire organization. This gets back to the SAP, the different modules, so that's going to handle any kind of accounting and shipping, logistics and operations and financial management and marketing and sales contracts. Salesforce is one of those organizations that's kind of morphed into getting into more of the enterprise applications, or at least attempting to. And so again, they've got CRM is where they started, where they're focused on the customer side, but now they're getting into logistics and operations and being able to manage all those different functions within a business to create products, to manage inventory. And so again, it helps the entire organization is really the focus there. Um, let's see some of the trends, obviously, software bugs and issues. These are kind of going away a little bit. So this is some of the things that you had to do, executable files and downloads. Again, most of these things are kind of happen happen automatically. They used to have to go in and choose, yes, I want to update, but a lot of these things now are just happening automatically, so that if there is an issue out there, they can quickly fix it and push out that solution to everybody. So it works out pretty well for most. The other thing I want to talk about real fast is the legality of software. Most software products are absolutely protected by copyright. Companies, obviously, this is how they make money. Most for-profit organizations are going to make sure that they are licensing their product to you in some way, shape, or form. This typically takes on the look and feel of a per user license. And so back in the day, you used to have to buy the Microsoft disk, and that disk had a key. It was like a 16 or 20 digit number you had to put in, and that key went with that disk and was only good for one kind of installation or use. Now, Microsoft has kind of moved to this idea of like, listen, let's just provide this service. You can pay us a monthly fee for it, and then you can use it wherever you are, right? Because I'm recording this video on my Microsoft Surface. I have an Apple MacBook Air and an iPad that I use back and forth, just depending upon the situation. And now I can use that one Word Excel processing via all of these different devices that I've got. And so they're changing their business model to ensure that the licensing is appropriate for how people are using their devices, if that makes sense. So the other type of software that's out there is freeware or open source. Again, this is where it's distributed for free, and the source code is open. And so if you want to see how they program something, you can actually open that up, look at the source code, make changes to the source code that you need for your organization, and then use it effectively. Microsoft's not going to allow you to do that, right? Apple doesn't allow you to do that to get to their source code. Their things are proprietary, locked down. You're not going to change their code, but other avenues are absolutely out there. One popular one is Firefox. So Firefox is kind of one of these open source things where it's maintained by a community of users who are constantly making updates and changes and adaptations to it based upon user feedback. The great thing about open source is that it is free, and it's usually pretty robust, very competitive in the market because the user group that's kind of maintaining that open source software wants to make it very effective for the end user. The problem is that it is maintained by a group of users who are doing it pro bono for free, and so whenever that group of users kind of dwindles down and there's only a handful of folks working on it, well, things don't happen as quickly. Again, a lot of open source things would be, especially in like web pages and web development, would be like a WordPress or a Blogger, very common things that people use. These are all open source and free. There are add-ons that you can pay for to make it use it differently or however you want to, but so those are some of the items that are typically open to the public. So okay, well that concludes section 3. Please read through the paragraph information for the business software in section 3. Finish the interactive Q&A, and then this will be it for week 1. Okay, have a good one.